In this video, I want to talk about finding the difference quotient for a function. So first, we need to figure out what a difference quotient is. I want to start by talking about the slope. So if you have a curved function, a function that doesn't have, or even if you have a function that's a straight line, you can find the average rate of change between 2 points by just finding the slope between those 2 points. So for example, we have these 2 points here and here. Now, the rate of change is always changing, right? Because it's the slope, and this is a curve, so the rate of change is always different. But I can find the average rate of change by finding the slope between those 2 points. So if I wanted to find the average rate of change between this point and this point, I could just find the slope between those 2 points and then figure out what that slope is, and this gives me the average rate of change. So the slope is equal to the average rate of change. And this is kind of like if you're in a car and you're not always driving 50 miles per hour, but you might be averaging 50 miles per hour. It's the same kind of thing. Sometimes you're going to be going slower, sometimes you're going to be going faster, but when you average it, the average is 50 miles per hour. Okay, so the average rate of change is the slope between these 2 points. So let's figure out what that is. So it's the y value at x2, right, minus the y value at x1. That's the same thing as saying f of x2 minus f of x1 over x2 minus x1, right? So this is just a different way of writing y2 minus y1 over x2 minus x1. Okay, so let's figure out what that is in this case. So let's make this x2 comma f of x2. Oh, I'm going off my page here. Let me write a little bit smaller. Okay, so we have x2 comma f of x2, and then over here, this point is, let's try a different color, x1 f of x1. And then remember that that's just another way of saying y, right? F of x is another way of saying y. Okay. So in this case, it would be f of x2 is 2, right? That's the y value. So 2 minus f of x1 is 1, 2, 3, 4, 5, 6. Minus 6 over, and then x2 is 1, 2, 3, 4, 5, 6, 7, minus x1 is just 0. So it's going to be negative 4 over 7. So in this case, the slope of this line is negative 4 over 7, and this is the average, so negative 4 over 7 is the average rate of change between these 2 points. Okay, so now that we know that, the difference quotient is kind of just a different way of making the difference quotient, or making the average rate of change easier to find. So the difference quotient is, we basically just say, okay, instead of x2 and x1, we're just going to have f of x, and then we're going to have f of some distance away from x, which we call f of x plus h. So the difference quotient looks at, instead of, here we're looking at the difference between x2 and x1, and we're finding the average rate of change. The difference quotient looks at f of x and f of x plus h and finds the average rate of change between them. So it looks something like this. F of x plus h minus f of x over x plus h minus x. And this, the bottom part, simplifies into just h, right? X plus h minus x is just h. So it's f of x plus h minus f of x. And this is called the difference quotient. And it's just a different way of finding the average rate of change between 2 points. The reason that we want to use this is that we're learning about it now because you're going to need to use it in calculus. And the difference quotient gives us a very efficient way to figure out lots of different rates of change all at once. And it gives us a way to figure out what happens as these 2 points get really, really close together. So if this point slides down and moves close to this point, or alternately, if the 2 points get closer and closer and closer together, the question of what happens then is a lot easier to figure out when we know what the difference quotient is. So we're going to start by just learning about the difference quotient. So the difference quotient is this, and I'm going to try to give myself some space here. So let me get rid of this stuff. So remember, though, that this is really just a different way of finding the average rate of change between 2 points. It's just that we're writing these 2 points as just x plus h and x instead of x1 and x2. Okay, so let's go ahead and use a function and we'll actually figure out what this is. So let's say that f of x is equal to 3x plus 2. Okay, so let's go ahead and figure out what the difference quotient is. So the difference quotient is going to be f of x plus h. Let me not rewrite all of that. So f of x is 3x plus 2. So f of x plus h is 3 times x plus h plus 2. Okay. Minus f of x. So f of x is 3x plus 2. All over h. Okay, and now we're just going to try to simplify it. So this is 3x plus 3h plus 2. And this is, we're going to just distribute that negative sign, minus 3x minus 2 all over h. So this is, now we have a positive 3x and a negative 3x, and we have a positive 2 and a negative 2. So we just get 3h over h, which equals 3. So this says that the average rate of change in this function is 3. Now that should make sense because the function is a line, right? And its slope is 3. So 3 should be the rate of change between any 2 points on that line. The average rate of change is 3 because the slope is always 3 on that line. So that should make sense. Now we don't typically use such a simple function though, so let's try a more complicated function this time. I just wanted to get us started with a very simple function. So again, I'm going to just erase a little bit here to give myself some room. All right, now let's try another function. Let's try f of x is equal to 2x squared plus 3x minus 4. Okay, so now we want to find the difference quotient. So we're going to start with f of x plus h. So that means anywhere we see x, we're going to plug in an x plus h. So 2 times x plus h squared plus 3 times x plus h minus 4 minus f of x, which is 2x squared plus 3x minus 4 over h. Okay, so let's see what we can do to simplify the top. So this part needs to be FOILed, so it's going to be 2 times x squared plus 2xh plus h squared. This can be distributed, so 3x plus 3h minus 4. We can distribute the negative sign, so it's going to be minus 2x squared minus 3x plus 4. Okay. All over h. Now let's look for things we can simplify already. I see a positive 3x and a negative 3x, and I see a negative 4 and a positive 4. So I won't rewrite those. And then let me distribute this 2. So we have 2x squared plus 4xh plus h squared, plus 2h squared plus 3h minus 2x squared. Okay, so it looks like we can get rid of a 2x squared. Oops, this is all over h. Good. Okay, now the last thing that we can do is pull out an h out of the top. So because we have an h on the bottom, so we can take h out of everything that we have up top. We have 4x plus 2h plus 3 all over h, and now h over h is 1. So our final answer is 4x plus 2h plus 3. And that is the simplified version of the difference quotient. And so the difference quotient is going to help us later on, but for now it's just a simpler way of finding the average rate of change. So in this case, all we would need to know now is what is x and what is h, and then the average rate of change is very easy to find. And that's how we find the difference quotient for a function.